We can definitely get started. Let's see. We're going to be going live, and we are definitely live. Hello, everyone, and welcome to another Data on Kubernetes community meetup. We are well into the 70s. All right, we've done over 70 meetups since we got started, and all of you are doing a fantastic job of becoming a part of that. Sharing is caring, letting folks know on Twitter, on LinkedIn. If you're not subscribed to us already, why not? It's super easy. You got the red button there. Just click it. Just a couple of housekeeping things before we get started. One of the things that we always want to let folks know is that we do have our co-located event coming up in KubeCon in October. It'll be 100% virtual. It will also be 100% free. All right. So as far as we know right now, the idea is to be as inclusive as possible. We're not going to discriminate on any sort of basis. We will also be having a DOK Students Day the week before. But for the co-located event we're doing on October 12th, I will leave the CFP that we have in here. Perhaps Cyan would be interested as well in giving a talk. If you're interested in giving an end user focused talk that relates to the topics that we're frequently dealing with, such as working with databases, stateful workloads on Kubernetes, then please take a look at the link that I've left in the chat right there. And feel free to send us your ideas. If you're not sure, I'd be happy to work with you on that. You have until September 1st to submit ideas for talks for, like I said, our co-located event in KubeCon, which will be 100% virtual. Now, for today's topic, this is not the first time that we've talked about chaos engineering. And why is that? Because it's super important, right? If we're talking about robust and resilient systems that have been battle tested and are really ready to go, you definitely need to get some chaos involved in how you approach development and how you approach working with Kubernetes. So today we're going to be joined by some of the most active people in this particular project, LitmusChaos, right? For whatever reason you haven't heard about LitmusChaos, but I imagine you have. There's a lot of really, really cool stuff. There are a lot of really cool people. So shout outs to people that I've interacted with already. Big shout out to Karthik and big shout out to Divya Mohan. Lots of interesting folks working on this project. Great CNCF project. They've recently come out with version 2.0. So that's why I'm being joined today by Prithvi and by Cyan, who's going to be sharing more information with us about what makes version 2.0 unique. But before we get to that, can you just tell us a little bit about yourself, Cyan, and how you got into this topic of chaos engineering in the first place?
Yeah, sure. So hi, everyone. It's first of all, it's great to be here. And just like he mentioned that 2.0 is out, and it's really been a long journey since 1.x to 2.0, and we are also going to share about that journey with all of you. But yeah, how I got started is I typically was looking into one of the Kubernetes workflows and how things work, and in that process itself, I was very intrigued in how to avoid downtimes, and that was one of the really important problems that I wanted to fix, that because it's really important to avoid that sort of a situation. So while I was exploring, and I came across this term of, I first came across Chaos Monkey, and I was very interested what this is, and then while exploring, I came across Litmus, and then that's where my interest began and where my contribution started. So that's mostly it. But about me, I actually am working at Chaos Native as a chaos engineer as well as a software engineer combined, and well, as a software engineer turned chaos engineer, you can call it that. But yeah, it's been a great journey because I've been contributing to that LitmusChaos project and also learning a lot along the way. So yeah, that's basically me. And yeah, so Prithvi, if
Prithvi, if you'd like to jump in, share us a little bit about your experience, because you are, I know few people in the CNCF ecosystem who are as active as you are, and I don't really think many who I would say are maybe more active. So anyway, but you're a person who's very, very energetically involved with this project, has a lot invested in it. Tell us about how you got started in it, and then maybe we can jump in a little bit more and find out about what's new in version 2.0.
Sure, absolutely. Thanks, Bart, for that amazing introduction, and thank you, Cyan, for introducing Chaos Native, Litmus, and Chaos Engineering. But I mean, you being a chaos engineer. And hi everyone, this is Prithvi here. I work as a community manager for the LitmusChaos project at Chaos Native itself. I think we'll move to a detailed introduction, but I got started, 1.5 years ago, we started, me and Cyan both joined this project as, we would say just mere contributors, me as a community manager, Cyan as a software engineer. And since then, I think being part of the CNCF ecosystem, since 1.5 years, there's been a lot to learn. From each and everyone, from you itself, Bart, and there are so many folks, Sayam, Kunal, Dan, and so many folks in the CNCF ecosystem itself, those who have taught me so much about community and community management. And running this project has been a great experience with amazing community members. I think chaos engineering is something which is a sought after technology, and everyone is looking forward to such projects, and Litmus Chaos has been vital in that space. I think I'll talk more when we get started, but it's great to be here.
Absolutely, and great comments there. And I think this is maybe one of the things that is always interesting to address in our community is the issue of, or the topic of, when can I start working with data on Kubernetes? When can I start working with chaos engineering? And I think just to make it super clear, whether you're a 20-year veteran or a 20-minute beginner, you have a place in, whether it's in Litmus Chaos or other CNCF projects. You can contribute with a positive attitude. You can contribute by reading documentation. You can contribute by attending meetings. Nothing is going to be too beginner. And I think one of the important things that I want to see here is, and that we talked about with Karthik when we had on the meetup as well, is like, how can we get chaos engineering to not be siloed, to be something that's shared and understood by the whole organization, the stakeholders that have to be involved in that. But I'm sure we'll get to that once you start your presentation. That being said, so Cyan, if you want to take it away, share your screen, go for it.
Sure, I'll perhaps share my screen.
You'll share your screen. Okay. Sorry, telling the wrong person is the wrong thing. No worries.
Yeah, just give me a second.
Okay.
Is my screen visible?
It most certainly is.
Yeah. Just give me a sec.
Yep.
Yes. So let's get started. I mean, that's what we are going to talk about, introduction to LitmusChaos 2.0, but I think there are a lot of new folks who are joining in. So I think it will be good to introduce chaos engineering again. I think a lot of people might have watched the episode with Karthik, but I think the best part will be introducing chaos engineering, or talking a little bit about chaos from scratch, and then moving on to Litmus, what Litmus is, 2.0, the journey, and then features of 2.0. So
does this mean are we going to hear about Netflix? No spoilers, but maybe we're going to hear about Netflix. Anyway, sorry, go ahead.
I mean, yeah, we'll be talking about Netflix a little bit, of course, but let's just start by introducing ourselves. So I mean, we already talked about us a little bit, but I mean, my name is Prithvi. We started off at Maya Data at this project. I mean, obviously, as we are in the data of Kubernetes community, this project started off to test OpenEBS. I mean, OpenEBS is a project based on cloud native data management. Another CNCF sandbox project at Litmus was written way back in 2017, 2018, early 2018, where it just started to test OpenEBS I mean, we were looking for chaos engineering tools out there in the market, and it was none were available, or maybe they were available, but they weren't as good to test OpenEBS. So we started off writing our own tool set, and eventually it became a CNCF project. So obviously that's something one must be glad about. But yeah, it started off at Maya Data, and the project became so successful that eventually it became a company itself, Chaos Native, which I'm part of. And obviously, as you know, I'm the community manager for Litmus, the Litmus project, and alongside that, doing a lot of community work. I mean, the CNCF ecosystem is amazing. So I mean, working as a co-organizer at Chaos Carnival, we organize chaos engineering meetups every last Saturday of the month. So folks, feel free to join. I think I'll be sharing some links while the talk goes on. So I think Bart will be glad enough to share those links in the YouTube live chat. And then obviously KCD Bangalore, I mean, Kubernetes Community Days is happening around the world, and I was glad enough to be one of the organizers there. I'll allow Sayan to introduce himself, and then we'll move on with the agenda.
Thanks, Prithvi. So, like I already mentioned, I am Shayan. I'm a software engineer turned chaos engineer at Chaos Native, and I've been contributing to this Litmus project. It's been over a year, I'd say, and I've seen all the ups and downs of the project. And the best part about it is, since the launch of the 2.0, I've been involved in the creation of this UI, as well as a lot of intricate details inside of it, like creation, workflow creation, and a lot of algorithmic changes. So I'm really proud that people are really enjoying it. So it's been a great journey for me overall to contribute to this project, and also like make it a level up for everyone to enjoy. So yeah, that's about me. Prithvi, you're on mute.
Apologies, sorry. Yeah, so thanks a lot, Sayan, for that introduction. Moving on, we'll be talking about the agenda, of course. We'll be starting off with chaos engineering, what exactly it is, and then introduction to Litmus. We'll just introduce Litmus for you all. And I think, I mean, it's been great to see so many students taking part in the data on Kubernetes community, and that's why we felt that it would be great if we start from scratch. So we'll be talking about the journey, and then Sayan will be taking forward talking about the architecture and the components and how 2.0 has come up, and then we'll just move on to a demo and what's the future roadmap, and obviously contributions in the end. We love people contributing. Contributions are the key for a community to develop. So I think we'll be ending with how you can contribute to Litmus. So let's get started. So before we talk about chaos, I mean, before we move on to what chaos engineering is, it's very important to understand what resiliency is, or what sort of a role does chaos engineering play in terms of resiliency. So when we talk about resiliency, let's talk about outages, the possible outages that can happen, and then we can move on to resiliency. So let's say, I mean, your system, in not just in the overall infrastructure space, but in the Kubernetes space itself, there are so many things that go down every day. I mean, with the adoption increasing every day, there are high chances that something or the other, a node, a pod, anything can go down. Where and what can be done to mitigate such outages, or what can be done to actually identify the faults, or where is this fault happening, and that is where resilience comes into play. And that is where we need to understand that resilience is nothing but the system's ability to stay afloat, stay strong in spite of a fault happening, in spite of an outage happening. Resiliency is something which comes into play there. So I mean, there are some examples that we'll be taking before moving ahead to introduce chaos in a very descriptive way. That is, what are the examples of resilience and weaknesses in the Kubernetes space specifically? Let's say a pod is evicted from a node. So let's say if the pod is rescheduled and the dependent service is healthy, that's the example of the system being resilient. But if the dependent service slows down or turns unhealthy, then that's a weakness, right? So this is something which happens on a pod level. Let's say what happens on a node level. I mean, the node goes to a not ready state, and then again the pod is rescheduled, dependent service is healthy. That is an example of a resilience. But in case the dependent service turns out to be unhealthy, this is an example of a weakness. And similarly, I mean, a memory leak in a container. So these are a few examples that happen on a day-to-day basis when we are talking about, I mean, what are the dependent services and how the system reacts and what might happen in a system on a day-to-day basis. So these are very, very naive examples, or examples which happen on a day-to-day basis. But as we go deeper, as we go into the complexities of a system, there are so many examples that can be taken of a possible outage happening every day, which leads to the concept of chaos, which introduced the concept of testing repeatedly. So what is chaos, that we'll understand later on, but let's understand how has it affected real world scenarios. I mean, in India, I don't know how many people are watching from India, but in India we usually have Big Billion Days or Amazon Great Indian Festivals, or so. I mean, in the West we have the Black Friday sales. So there are so many possibilities of an outage when there's there's a requirement for scaling, or there's a spike in the number of users, there's a spike in the overall usage time, or the overall users that are using a particular project. And that is where talk about Netflix. I mean, in India itself, there's a popular series called Sacred Games. I don't know how many people around the world have watched it, but when season 2 of that popular series launched, there was a spike in a different way. I mean, I don't think so many people have use Netflix. And unfortunately, Netflix India did go down for a bit. So I mean, that is where Netflix came into, I mean, in the fray back in 2012 or 13, where they introduced the idea of injecting a fault into a system, because downtimes and outages are obviously expensive. As you can see a few examples out here. I mean, Apple Store lost somewhere around $25 million, and then Delta Airlines. I mean, the airline sector is actually, I mean, there are so many. I will take a few examples: Delta Airlines, Air Asia, and then American Airlines. These have been starting to focus on how they can prevent their outages or their downtimes, or how they can basically make the system secure in production. So this is where the requirement of chaos engineering came into fray, that we needed a testing methodology when there's a spike in the number of users. There's requirement for scalability, and there are certain issues which bring the system down. What sort of issues can happen when the system goes into production or where the system is live? So that brought the idea of chaos. And chaos engineering is nothing but the idea or the process of inducing or injecting a fault into your system deliberately, and identifying what are the possible weaknesses, what are the possible outages, what can happen when the system goes down, when can the system goes down, or basically organizing or injecting fault into a system in a controlled way to ensure that the system is resilient when the system goes into production. Usually, usually people say it's breaking things on purpose, but adding to it, I think it's breaking things on purpose to actually make your systems resilient, and I mean, avoid unexpected disruptions or faults which might happen, or chaos, basically avoiding chaotic situations. And you test in production repeatedly to basically understand how your systems behave when there's a chaos that happens, and that is how you make your systems resilient. And I mean, we believe in the chaos first principle, and the chaos first principle is why to wait, why to go to that situation where the system goes down or you face a downtime. Rather, test now, test repeatedly, test first. And this is a principle which was, I mean, famously quoted by Adrian Cockcroft. He's an amazing guy, and he's a famous guy in the chaos engineering space, the VP of Resilience and Technology at AWS. But he's been vital in bringing the chaos engineering, technology to where it is right now. I mean, there's so many people who have done that, but I think thanks to him to bring in this chaos first principle. So moving on, again, chaos engineering. Why? I mean, we'll take the example of a Kubernetes application, or an application where there are so many layers where the resilience can be compromised in case there's a fault. So as you can see, this is example of a Kubernetes application used by so many people. So and Kubernetes adoption is has crossed the chasm already. I mean, it has reached majority as adoption. Even chaos engineering in some form or the other, we believe has reached majority adoption. But cloud native chaos, or basically the principles of Litmus, or where Litmus came into play, it hasn't reached majority yet. So it's yet to cross the chasm. But that is where chaos engineering comes into play. Why do you need chaos engineering? Because your application is not made out of one layer. There are so many layers to your application. There's your application, and then there's MongoDB, Kafka you're using for your databases, or any other cloud native application that you're using alongside. Then there are cloud native services, core DNS. I mean, again, OpenEBS, as you mentioned, these three layers were initially there, where we tried using Litmus to test them, but then again, Kubernetes services are there, and then your infrastructure platform services. So there are so many layers which can be compromised, or there can be an outage that can happen in any of this layer. So it's very important for you to test each and every layer, for you to induce a chaos experiment, a chaos test in each and every layer in some form, as and when required, to understand basically what are your resiliency goals, and what exactly can be a possible outage that can happen in one of these layers, and that is why chaos engineering is vital for you. And if you talk about chaos engineering running, who is someone, like who are the stakeholders or who need to use chaos engineering, then I mean it's not, initially we thought it's for the SRE. I mean, folks who are SREs or in the DevOps field, they are the ones who are the stakeholders and should be using chaos. But since the past, I think 1 year or 1.5 years, I mean, we have noticed that the developer persona as well has been focusing on chaos engineering and using chaos engineering. So I mean, chaos engineering is for everyone. Chaos engineering are for most systems. So that's something which makes chaos engineering important, not just for enterprises. Although when we started working on 2.0, the focus was also to understand the enterprise capabilities and how enterprises are using chaos engineering. But keeping that in mind, we also identified that even the developer persona, while developing the tiniest of projects, have required chaos tests in some form to make that project resilient. So moving on, I mean, where does chaos engineering fit in the DevOps loop? It fits everywhere. I mean, the feedback loop of the DevOps, basically the DevOps loop, which acts as a feedback loop, gets activated through proactive testing or through, testing repeatedly in production. So I mean, as I mentioned that, chaos engineering fits everywhere, and it's obviously even in the DevOps loop or in the DevOps space, chaos engineering can be used to test anywhere and everywhere. I mean, you can test in pre-staging, production, staging, or in your developer environment. So I mean, the chaos engineering is not specific to production, although we talk about activating the DevOps loop by proactively testing in production. Or basically, the idea of chaos engineering was initially to test in production to secure your systems, but today I think everyone is testing using chaos engineering tests to test on all stages of a software development. So test first and don't wait. So here are 4 simple steps, which are basically how chaos engineering is practiced, or basically how chaos engineering is induced. But before that, I'll just take you through the principles of chaos engineering, or the initial principles of chaos, to just bring that idea. I think Karthik might have shared this when he delivered his talk, but these principles are very vital. It's an open source document written in, I think, most of the languages, which talks about what chaos engineering is and how exactly chaos is practiced, or basically what are the steps or principles that act when ideally practicing chaos engineering. So initially you need to build a hypothesis around the steady state behavior. So first you understand what's the steady state of your system, as in how does your system behave when it's in steady state, and then you build a hypothesis around it, so that you can focus on the measurable output of a system. And because usually the focus is on the attributes or the internal attributes of the system, but what is important is to focus on how does your system behave in a steady state. And then you vary real world events. What are the real world events that are possible? What are the potential impacts, or what are the impacts that can happen when there's a failure, or when there's a server that dies, when there's a malfunction or a non-failure event, like as I mentioned, a spike in traffic. So you need to vary those real events, and then you run experiments in production. As I said, chaos engineering started with talking about testing in production. So I mean, every system behaves differently, and that is where you need to understand how the system will react when such varied real world events or experiments happen, and in production, because that's the eventual goal. So and lastly, you need to automate your experiments, obviously, because the world has shifted towards automation, and people cannot run one by one experiment and then another experiment. So think I mean, experimentation needs to be automated. Chaos engineering needs to be an automated process, and that is one of the principles of Litmus as well, where the focus is on automating chaos. And lastly, obviously, you need to minimize your blast radius. I mean, experimenting in production has its own flaws, or that is where a cultural change or a cultural shift is required, right? I don't know, people who are watching right now might know or might have seen in their enterprises as well that there's people are still scared or reluctant to use chaos engineering or practice chaos testing in their companies. So I think, that's why this principle comes into play, where I mean to avoid short-term negative impacts, or to avoid any sort of negative impacts, you got to be responsible, and then you need to focus on the cultural shift. So that is where minimizing the blast radius is important. So as you can see, this is how these four simple steps come into play. That is, identify the steady state, hypothesize, experiment, and then you adapt according to your cultural changes and minimize your blast radius. So from that sort of a workflow, we created a workflow which typically talks about how chaos engineering is run. You identify your steady state conditions, introduce a fault, something like a pod delete, pod CPU hog, node CPU hog, memory loss, or any sort of a chaos experiment. We'll move to that when we talk about the chaos hub. And then, are the steady state conditions regained? If yes, the system is resilient. But is the system resilient completely? No, right? There are so many possible faults that can happen. So you inject a new fault and you continue this testing process. But let's say a weakness is found, then you fix that weakness, and then you again continue testing. So you fix it, and then you again, this loop goes on altogether. So this is how chaos engineering is practiced in production. This is the workflow of it. And in case you have any questions, feel free to put them in chat. We'll be answering them later on. So moving on, how is chaos engineering practiced typically? As of now, as I mentioned, only the SRE persona has been focusing on practicing chaos engineering, but it's still moving on to the developers. Developers haven't engaged in chaos engineering that much, but this practice of how it's done typically needs to change. That is something which is very vital. So it's usually practiced in game days, where a certain application or application specific to the company is taken, and that is where chaos is induced. The few experiments that are specific to the application or specific to the company are induced, and a game day is organized to basically note down the results, monitor, observe what exactly is happening when such sort of chaos experiments are induced in the system. And then it's really integrated into the CI/CD. As I mentioned, it's part of the DevOps loop. So CI/CD chaos engineering is also pretty vital or important when we talk about chaos engineering, or when we talk about chaos engineering moving into CI/CD. I think it's pretty important, and that is where also observability comes into play. It's not a commodity, rather it's pretty important. You need to see where chaos engineering exactly is happening, or where is your system going down, where is the chaos being induced, what time the chaos runs, and when does the system go back to your normal state or the steady state. So I think this is how it's done typically, but this practice needs to change. More and more people need to adopt, test your systems at all stages, and observability. And I think one more term we'll come back to later on, that is GitOps. These things need to be brought into chaos engineering, because that is what defines the next principles, or not just the principles of chaos engineering, but the principles of chaos engineering in a cloud native way. You need to do it in a cloud native way, and that is what, or those are the principles on what Litmus was built on. So moving on, as we have talked about Litmus so much, Litmus, what exactly the Litmus is? It's a CNCF project. It's 100% open source, and it moved into sandbox last year June, and hopefully moves into incubation sometime by the end of this year, or hopefully soon. It's an open source cross-cloud chaos engineering framework, which allows you to induce chaos tests according to your need, according to your requirements. Its initial mission was to help Kubernetes, SRE, and developers to find weaknesses, but now the idea is to even induce chaos in non-Kubernetes platforms and run, chaos on different sort of platforms: AWS, Azure, GCP, VMware, bare metal, etc., etc. So that is what Litmus is, and it has these are some stats that I'll talk about. I mean, it has 50 plus chaos experiments, plus it provides you with an SDK where you can write your own chaos experiments, bring your own chaos. I mean, bring your own chaos is something which rarely any other chaos engineering project provides. I mean, we can move on to differences if it comes as a question, but these are a few stats. And I mean, before moving ahead, I think I'll take you to the chaos hub and all the various resources of Litmus, how you can get started, what's this chaos engineering project about, and all that. We talked about the history already, but let's just take a look at the other stuff. So I mean, this is the journey of Litmus. Before moving ahead, we'll just talk about the journey. I mean, initially it was just a tool to test another tool, but then it was made open source, and then there were individual experiments. Individuals started inducing chaos into their systems, and it was made a CNCF project, became part of the CNCF. There was a chaos hub that was created. It is a marketplace which allows you to basically pull your own experiments, pull the experiments that are out there, or upload your own experiments. Just write your own experiments or Go, Ansible, or Python, and then you can put them on the marketplace, or you can have chaos hubs in two ways. I think Cyan will cover that. And then obviously scheduling and all that was obviously something which was part of 1.x, and it was already part of the 1.x features. But with 2.0, I think a lot of new features came into play. Before I talk about 2.0 or introduce 2.0 to you, let's just take a look at the chaos hub. So as you can see, chaos hub, this is a marketplace. I mean, you can see, just give me a sec. Yeah, so these are the experiments that are out here already. Experiments based on generic Kubernetes chaos. They are already out there. You can pull, you can install by using the Helm chart, or you can use the YAML file to install the Litmus operator and inject chaos. So generic chaos experiments include these Kubernetes based chaos engineering experiments. As you know, it started with Kubernetes. There's a pod delete, pod CPU hog, and so many more experiments. But there are chaos engineering experiments for GCP, Azure, AWS SSM, and then Kubernetes, AWS, VMware, CoreDNS, Kafka, OpenEBS, Cassandra. So this is the marketplace from where you can pull your chaos, or you can obviously write your own experiments. And as you can see, you can contribute your own experiments. And these are the revamped docs. I think this docs help. These docs help you to gain access to a lot of things. You can explore Litmus. There are tutorials out there, advantages, advanced user guides, and so many things. The links will be shared while the talk goes on. And if you want to use check out the version 1 docs, then you can redirect yourselves to v1/docs.litmuschaos.io, and you can find the docs for 1.x as well, a version that is being used by a lot of users right now. So moving on to 2.0, I mean, I'll just introduce the features, but I think Cyan will be talking about it. I mean, it already possesses all the features of 1.x, but then it also allows you to create custom workflows. Workflows are nothing but inducing multiple chaos experiments together. And there's a user and team management, as we talked about, keeping in mind the enterprises. And I mean, it was necessary for multiple folks to run chaos experiments together, or teaming was a very important functionality which helped various teams come together and run chaos. There's an introduction to a chaos center, which was a central management center, or the UI, where you can manage all your workflows. You can monitor your experiments, you can analyze, and you can do so much more. And then monitoring and observability, obviously Prometheus metrics were used to monitor them on Grafana, but then we created an internal dashboard which is available on the chaos center itself, where you can monitor and observe what is exactly happening. And then you calculate your resilience score, if your systems are resilient or not, how did your probes work, and how the health checks and the native custom checks were carried out, and what's the resiliency score of your application. And then you manage your workflows and scale them with GitOps and the custom image registry. So with this, I think the last thing we'll be talking about are advantages. I mean, there are so many advantages. We have not jotted it down because when it comes to comparison, then obviously Litmus as a tool, the other tool sets out there are great, but Litmus as a tool set has been adopted by the community, loved by the community, and is community collaborated with monthly meetups happening. So the end users have been vital in coming out and putting out these functionalities and features and enhancements, and that is where chaos engineering has become much simpler, much faster, and much easier for the users to use. So with this, I think we can take up some questions and move ahead with Sayan talking about the architecture and obviously the journey ahead, the features, and the obviously overall demo. But yeah, we can take some questions. Me and Sayan can answer them, and then we can move ahead.
Okay, from a technical perspective, you mentioned how this is frequently focused on SRE teams and things of that nature. But I think, like you said, conceptually, a lot of the ideas here, although they might have some technical side to it, a lot of it, like you said, is kind of building on the DevOps principles. What do you think are generally the biggest challenges that folks have when they start introducing chaos engineering into their teams?
I mean, see, there are a lot of challenges, to be honest. The first and foremost is the cultural challenge, as I talked about. People haven't shifted to chaos testing yet. I mean, QA testing, black box testing, and I mean, penetration testing. All these forms of testing have been there. But when we talk about the overall cultural scope, then that is the major challenge which comes into chaos engineering. And then secondly, obviously, teams are not aware of what chaos engineering is. A lot of people, lack of skill is another challenge which is faced by a lot of people. I mean, if you go out there are so many people who want to run chaos, but there are so less number of chaos engineers out there. I mean, people are looking for chaos engineers every other day in the job section. We are wanting chaos engineers. So the skill set and the understanding is still not there. There's a lack of understanding, and how chaos engineering can be introduced. People are scared that what if the systems go down? How will the system scope up to such sort of chaos testing? And the infrastructure is not available. That is one part of it. And then secondly, obviously, chaos engineering has developed a lot over the years. I mean, we talk about Netflix and how Netflix started off with Chaos Monkey, and there were monoliths back then which were tested using such chaos engineering tools. But then while we move on to the cloud native paradigm or the microservices architecture paradigm, that is where inducing chaos has become more vital, because systems are getting more complex, and obviously such sort of testing is vital. So I mean inculcating this knowledge, and then obviously making our systems ready for it are two vital things, two vital challenges. Or maybe a couple of more challenges I would talk about is that the monitoring is not in place. People don't have certain sort of functionalities which run hand in hand with chaos. I mean, there are so many enterprises that are still trying to adopt the SRE principles or manage their SLAs, SLOs, and SLIs. So all these things need to be sorted, or people believe that if they aren't sorted, then chaos engineering can't be practiced. So I think once if the plan comes into place, then obviously adopting chaos engineering becomes easier.
Very, very good. Awesome. Let's crack on with Sayan then, shall we?
Sure. But thanks a lot. If there are any questions, then we can take them up as we go on, and I'll be sharing links while Sayan moves ahead with the talk. So I'll stop sharing my screen. Thank you.
Thanks, Prithvi. So I would share my screen. I hope it's visible. Can you see the? Yeah. Oh, all right. Okay. So we covered most of the advantages that Litmus 2.0 offers and what chaos engineering is. It's open source, what Litmus is, the hub, and the general availability of everything that's out there as of now. But I'm going to talk about the architectural overview. I'll obviously keep it simplified, and also what are the features that 2.0 offers, and also how you can get into 2.0 and how you can also start running your workflows in less than about 5 minutes with this new form of chaos workflow creation or construction. So to start off with, we are going to look at this particular architectural diagram, which is, if you take a look at it, it starts with the SRE and it ends with the chaos execution plane. So the chaos execution plane is, let's consider this as our target application, or what we want to do, or the final thing. And the start, which is the SRE developers or QA, is basically the persona that we are targeting. So in this case, let's say you as a user are targeting, or you want to run a chaos workflow, which is the blue box, which is just next to it, which is called create a chaos workflow. So in this case, your application is WordPress. You want to do a pod network latency chaos experiment on your WordPress application, or whatever your application is. And you want to do this on your MySQL database. So you have your WordPress application. You want to do a network latency chaos injection in your database connections. You want to see what happens when certain data, there's a network latency when you move data from your application to when you store some data in the MySQL database, and there's a network latency. So that is the entire workflow that you want to create with the help of Litmus. Now, this entire flow would be smashed up and considered. The construction would happen in the Litmus Center, which is also called as Chaos Center. And this Chaos Center is a part of this entire gigantic block called Chaos Control Plane. So what is in the control plane? We have the authentication server, the GraphQL server, and the MongoDB, where we actually store all the events that happens while we do the chaos injection and everything. And there's also two external things, which is analytics and GitOps, which we'll come to later. So this entire block is the chaos control plane, from where we control the chaos construction and injection. Now, once we do the chaos injection, this is the other side of the architecture, which is the chaos execution plane, where our chaos injection finishes, or triggers and then finishes. So the chaos agent is actually the component which handles the injection of chaos in your target application. So once you construct this pod network latency workflow, the chaos agent would be the one where you are injecting this workflow on. So let's say your application, this WordPress application, is sitting on a certain cluster. With the help of chaos agent, you would be targeting that particular cluster and that particular application sitting on your cluster with the help of chaos agent. And then we'll have these other sub-dependent components like Argo workflow controller, the event tracker, and then Prometheus for monitoring, and all those infra components that are sitting there. And with the help of chaos agent, we'll be triggering all of them, and the chaos will be injected. So this seems a little complicated, but we'll move forward and we'll actually show you how this is done, and it'll be pretty simple once we get to know this. So once the injection is done, we can see something called as a chaos workflow CR. So that is actually what we see when we get to the visualization of the workflow. And there are two important CRs, which are the chaos experiment and engine. Experiment is what holds the boilerplate properties of the experiment. So in this case, boilerplate properties of network loss for network loss experiment. And chaos engine is the CR, which actually does the tunables where we can tune that particular experiment to our needs. So let's say by tuning, I mean we can change the amount of latency, we can change which target application we want to choose, and those kind of things. So we can do all sort of tuning with the help of this engine CR. And chaos operator is another CR that is like the heart of Litmus, where which actually helps validate a lot of properties going around the policies, and also if the target application is present in a cluster or not, whether what you are trying to do is valid or not. So all these kind of things are handled by the backend infra, which is the entire CR section that I just showed you. And with the help of this entire architecture, we can target Kubernetes applications, bare metal applications, even non-Kubernetes applications like GCP, AWS, Azure, and even VMs like VMware. So moving forward, this is what I'll be showing you, and based on the time that we have left, we can add one more workflow on top of this. But yeah, so generally starting with, we have two major core components with the release of 2.0, which is the Chaos Center and the Chaos Agent. Now, what is Chaos Center? It's basically one single source of truth, where when you try to do chaos work, when you try to construct any chaos workflow, monitor your workflow, look about different ways of observability, try to achieve multi-tenancy, anything you want, Chaos Center is the way to go, because it's the single source of truth, or the major management center, that you can call it that. So from the Chaos Center, we'll be constructing workflows, we'll be injecting chaos on different applications, and we can also visualize and see the injection happening in real time with the help of Chaos Center. Now, what is Chaos Agent? Agent, on the other hand, is basically the target application or the target cluster where we want chaos to be injected. So let's say we have a lot of applications sitting on a certain cluster, let's say cluster D, and our chaos center is sitting on cluster A. Then chaos agent can be installed on cluster B, and the cluster B would be called as a chaos agent in this case, because we will be targeting applications sitting on cluster B. So that is the general concept of it. Now we can connect multiple external clusters as well to our chaos center. And by that, I mean, my chaos center can be sitting on GCP or EKS or AKS or anything. And my chaos agent can be sitting on any other cluster running on any other vendor. So in this case today, the demo I'm going to do is my current cluster is sitting on Minikube. If I wanted, I can have my target cluster sitting on Azure or AWS or any other vendor, and I could choose applications that are running there to induce chaos on. So that's the general idea about this. If I just go to the chaos center to give you a better idea. So this is what the chaos center looks like. So we have this general dashboard area where we have chaos agent, which is a sub characteristics. If you take a look at the architecture diagram, chaos agent is a sub-component of the entire flow. So we have this entire box chaos control plane where chaos center is sitting, and then chaos agent is a sub-component of the chaos execution plane. So we have the chaos agent sitting right here. And in the chaos agent, we have a self agent, which is basically wherever you install Litmus 2.0 on, that cluster gets automatically picked up as the target cluster where you want to induce chaos on. So in this case, since I have this running on Minikube, which is this Minikube setup that I have, my self agent in this case is also Minikube. So whatever chaos injection I do today in this demo would be run against Minikube. But just like I mentioned, it can be AWS, Azure, or any other vendor that I choose. So to connect any other external vendors, we can of course click on connect the agent, and we'll have a binary called LitmusCTL, which you can download and use to connect any external agents. And then we can have multiple agents sitting right here. We also did a test recently where we connected over 1,000+ agents in a single chaos center. So it is pretty seamless and pretty scalable. So you can definitely go about it. So you can have multiple agents connected right here, and you can choose which agent you want the chaos to be on when we schedule this particular workflow. So that's that. Now, if I come over to the features that are there, let me take you through them one by one. So starting off with the chaos center, what exactly can you achieve with chaos center? So you can create chaos workflows with the help of chaos center. Now, what I mean by that is you can chain multiple chaos experiments. And in this case, I just give you an example of pod network latency. So you can, let's say, chain pod delete, pod network latency, or a code DNS pod delete, or any sort of experiments that you want, and you can jam them up together to form a single chaos workflow. So when you inject that workflow, all the chaos experiments associated with that workflow would be run against your target application. So you can do all this via the help of the UI, which earlier you had to do via the Litmus 1.x Litmus operator, and you had to do this one-on-one individual experiments at a time. So with the creation of 2.0, we can do this entirely on the UI, and we have the option to chain multiple experiments, and we can also sequence them either in parallel or sequential. So we can bring up the order of the experiments as we want, and we will also see this when we do the demo. So there's there's also an option to do this in multiple ways. Let's say it's there to create workflow from templates. And what are templates? Basically, let's say you have a specific workflow in mind, which is not present currently. So you can create, at the first time, you would basically create that, and you can save it as a template, so you can use it again and again in any future recurrences. So and custom workflows, obviously, like I mentioned, where I just talked about pod delete, pod network loss, and code DNS. These are like custom experiments, custom workflows that I want to create by selecting individual experiments. So I can do this by selecting the custom workflow option. And this is obviously using Chaos Hub. So we can pick experiments from the Chaos Hub, or we can also connect our own hub, and we can take experiments from our own library. And also we have pre-created YAML, so we have 3 or 4 of them, and you can definitely try and use them. In this demo, I'll be using one of them. And the good thing about it is the application is also installed when you use this pre-created YAMLs. So by that, what I mean is, let's say I want to do a pod delete. The application which I want to do the pod delete on would also be installed, and then pod delete will happen on that application. So I don't need to have a predefined setup ready in order to do that. So that's pretty cool. Thirdly, we can control experiment editing. This is what I mentioned at the first point as well. So we can we can control the sequence of this experiment. So it can be purely sequential. We can have 2 experiments running parallelly or so, and that depends on how we want the experiments to run. And we can have single and recurring workflow creations as well. So we can, what we mean by this is we can have cron workflows as well. So you can create cron jobs with the help of the GUI itself. And if you have your chaos center running, the cron would be continuously running and in the particular schedule that you've created. And also we have control over the experiment priority. So let's say you have 2 or 3 workflows and one of them is not that important to you. So we have the options to attach weights with the individual experiments. So if you give a low weightage to a certain experiment, then that experiment would be given low priority over the ones that you have given a higher priority, higher weightage, which means high priority. So the advantage of this is, if you give something a lower weightage, then your resilience score at the end of the workflow, at the end of the chaos injection, would not be affected that much because it was not that prior to you. So that's the feature set in the chaos center. Now, if we come to workflow management, we have also management of these workflows using GitOps. Now, we have an entire section dedicated to GitOps, so I'll be coming back to this again. But yeah, this is basically rolling out a lot of automated changes using GitOps. I'll be talking about this soon. And there's also custom image additions, which means you can use your own private image from your own private servers, obviously. And this is just in case you want to do something advanced and you do not find that requirement in the images that we provide already. So you can create your own images and add them in the workflow. Also, you can measure and analyze the resilience score. So once you set the weightages and everything, then we actually calculate the resilience score for your workflow. And there's an analytics section which you can use to analyze and see what the resilience score is, why was it that way, did anything affect my workflow. And there's also a concept of probe, which helps here. And probe is basically pluggable checks that you can induce in your workflow. What I mean by that is, let's say you have a certain workflow and you want to add a certain check in your workflow. Let's say if my HTTP endpoint is healthy or not, I want to trigger, or I want to just do a GET request or a POST request in my HTTPS endpoint, and I want to see if post chaos it is available or not. So you can do that via an HTTP probe. You can also write shell scripts using CMD probe. You can also do PromQL queries using prom probe, and there's also Kubernetes. You can also use KES probe. So there's a lot of options when it comes to probes. When it comes to enhancing your workflows with the help of probes. So definitely that's something to check out. Now, multi-tenancy with the release of 2.0, this is something also which came into the picture, which actually allows you to do teaming and user management pretty seamlessly. So you can create users from your sitting on your clusters. So let's say you have a chaos center that is sitting on your particular clusters. You can create a team of multiple users, and you can give them access to your particular project, which is connected to your cluster. So they do not have to even open a certain cluster to get access to your project. They can be sitting on some other computer or some other environment, and they can control workflows and run workflows and control the scheduling or cron jobs sitting separately and not even touching your cluster. So that is something that is also included in the 2.0 release. And also authentication is provided, which means you will have security. And also there's an onboarding process, which is smooth and you can skip it basically if you do not want that to be a burden first time you log in. But yeah, there's authentication involved. And also you have role-based access control on each of the users that you create. So when you create teams, when you invite people to your project, you can choose whether they want to have owner access or a viewer access or an editor access. So basically, if you give someone a viewer access, they won't be able to schedule workflows or even do any kind of admin related stuff like, create a new user or something like that. They'll be only able to view what you're doing and also view the visualizations and download reports and those things, and they won't be able to affect anything that you do as an admin. and also support clusters and namespace scope. So with the installation, you have both Helm installation as well as namespace scope installation, and namespace installation which comes in cluster scope as well as namespace scope. So when you install this in a cluster scope, you obviously get access to any and all namespaces you create in that particular cluster. So basically, Litmus would have access to the entire cluster, but namespace in the namespace scope, you would have access to a certain namespace in your entire cluster. So that is where it's helpful. If you are working in a shared cluster, or if you have just access to one particular namespace in your entire cluster, you can definitely go forward with installing Litmus in that namespace, and also installing applications in that namespace, or even targeting applications running on any other namespace if you have the correct permissions. So that's that. And also monitoring and observability comes into the picture, which is you can connect a data source. You can visualize the different runs that are created as a part of this, let's say, schedule, or a single schedule, or a cron schedule. You can compare different workflows. At the minimum, it's 2, obviously. You can compare 2 or more workflows, and you can also download the report that is generated from the comparison. So you can even share that with your team and product manager and anything. You can upload your own dashboards, which is Grafana dashboards. If you do not like the interleaved one, you have your own dashboards that you have created, you can definitely upload them. Or there's also dashboards available by the community, so you can definitely download it and upload the same. You can tune dashboards to your preference, which is you can change queries, you can change the Prometheus endpoints, or however you have set up your monitoring, you can seamlessly integrate that. And definitely you can monitor chaos in real time. So it gives you the option to see chaos observability in real time with the help of monitoring. So this is the section that I was talking about when I talked about GitOps. So what GitOps offers you in terms of chaos engineering is basically it would integrate seamlessly with any Git-based SCM, any source control management. So if you have a Git-based SCM, then that would act as a single source of truth, provided you have enabled GitOps. What I mean by that is, since I told you in the architecture diagram that we use Mongo, so the Mongo dependency would completely switch off, and we'd be using Git as a DB. From then onward, if you switch GitOps on. And what will happen is you will be managing all your workflows and events from Git itself as a single source of truth. Now, since it's a bi-directional flow, that would mean that if you change anything on Git, let's say you ran a workflow and you changed anything on Git, that would automatically trigger a rerun of that particular workflow, and that is done by an event trigger CR that we use. So it's a bi-directional flow. So anything and everything you do when you have GitOps on, either in the Chaos Center or either on Git, would be synchronized. So, and also this tracks events and triggers chaos, which is the event tracker that I just talked about. So provided your chaos workflow is subscribed upon that particular microservice, event tracker microservice, then GitOps would actually synchronize what events are happening between both the two sources. And last but not the least, non-Kubernetes chaos. So with the new release, we have an option to do chaos on non-Kubernetes entities as well. So you can target bare metals, and you can also target infra resources that are running on, let's say, AWS, GCP, Azure, and VMware. So basically, you can do this by creating secrets, and the chaos center would take the secret as take the IAM policies and rules that you have stored as a secret, and then it will be able to target the resources that are running on AWS, GCP, or any other provider. So that's all the features in a gist. I hope I didn't overdo it, but okay. So for 2.0, in a tabular form, in a gist, what we have is previously we had singular experiments. Now we have chaos workflows in total, where you can clutter up multiple experiments. It was per user previously. Now we have teams or multi-tenancy. It was per cluster in 1.x. Now we have an organization where it's pretty much cross-cloud, since we have the chaos agent concept now. We only had public chaos hub previously. Now we have public as well as both private chaos hub. So if you're using a private chart in a private repository, then definitely you can connect it via SSH or access key. And also previously it was CI only, now it's CLI only. Now it's CLI as well as GUI. And we also have external capabilities like GitOps, scalability, high availability, integrated and interleaved monitoring with 2.0. So with that, it's finally demo time, and I wanted to show all these capabilities in action. So what I meant by private chaos hub is also something like this, which I have a demo chart, which is like my own private chart. And the public one is sitting right here. If I go to chaos hub, this is my public hub, which has all the different chaos charts. I'll see all the different experiments that are there on hub.litmuschaos.io, which we can share with you. And that is like a single most repository where all our experiments are hosted. And this is also embedded or built in when you first install the Chaos Center. So you'll get all these experiments predefined when you install this Chaos Center. And we have these three as the predefined workflows, which are already there for you. Now I can also connect this external repository, which is a private repository, as you can see, with the help of this option. If I go to connect a new hub, I have the option to connect either a public or private hub. Obviously, public is pretty straightforward. You just provide the URL along with the branch name, and that should be connected. But for private hubs, you can either provide the access token, GitHub access token, or the SSH key, which if you click on this will be generated for you. And you need to provide the Git URL and the branch. So this would be the SSH URL and the branch if you choose SSH provided. So that is a way to connect private hubs to your Chaos Center. And also, if I come over to settings, I have the option of GitOps adding a custom image registry, which I just talked about. You can use the custom values right here. You can enable GitOps from this section. Currently, it's locally in Litmus, which means we're using Mongo. We have an option to do user management. So as an admin, I can create new users and I can invite those new users that I created in my team. So I currently do not have any. And this is my account. So that's that. Now let's just go ahead with the creation of a workflow. So what we are going to do in this creation of workflow is basically we'll be doing a pod delete on a sample microservice application which is called Potato Head. Now Potato Head is basically a CNCF microservice sample application which gives you all these different kind of microservices like the left arm, the right arm, the hat, the legs, the left leg, right leg, and all these individual parts are like microservices. And we will be doing pod delete on these microservice applications, and we'll be seeing them live in action. So to start with, we have to select which chaos agent we want to target. And in this case, since I only have Minikube, so I'll be just given one option. If I had multiple, I can choose. So I'll be selecting the self agent, which is Minikube. Now here is the different ways of creating the workflows, constructing. We have an option to do this from predefined, which is the one we are going to do. Now we have an option to do this via template. Currently, I do not have any. And this is the option where you can choose which hub you want to choose. So this is the public one that I have already built in. And if I had connected this demo chart, the private one, I could have also seen this here and I can use my private experiments. And I can also import a certain YAML from my local setup if I had a YAML with all the configuration. So I'll be choosing the public, the predefined experiments, and I'll be selecting this Potato Head experiment. So a good thing about this is when I select this experiment, it will be installed in my system, which I will show you, and also it will start injecting the chaos on this particular application. So if I click on next, this is like a area where I'll be able to see the name of the workflow, description, which namespace it is going to install in, and also target the application on. So once I do this, I would be able to see a rough visualization of what exactly my experiment is going to look like once it is executed, once it is injected. So I have a potato main pod delete chaos experiment. And this is the sample visualization. So it will first install the application. Application is the Potato Head application. Then it will install the chaos experiment, which is the pod delete experiment. Then it will inject the pod delete chaos experiment, which would mean it will delete pods. And then post that is done, it will revert all the chaos that happened. So it will gracefully clean all the resources that were created in your cluster as a part of the chaos. And it will post that, it will also delete your application. So these are like parallel steps. It will happen in parallel, obviously. So it revert the chaos and simultaneously also delete the Potato Head application that was created as a step one. So that is the way we are going to do it. Now, if I go to just edit YAML, there's just one minor thing that I would change here, which is the type name. I would call it weak. Now, if I just go over the YAML, these are like chunks that are really easy to understand. So what it does is basically it's trying to tell that we have a template with these steps. So it will install the application, install the experiment, run the pod delete experiment, and run revert chaos and delete application in parallel. The same thing that you saw in the GUI is the same thing in the form of a YAML. Now we have the chaos engine, of the pod delete, where we do all the tunables like I mentioned before. So we'll tune which app label it will target. We'll tune what is the app info, like the namespace of the particular application that it's running, where the potato head is running, and then certain specs where we also have a probe, which is the HTTP probe, which is checking the health of our local potato wherever it's hosted once it's installed. And we have some ends, which is like what is the total chaos duration, the interval, and those things. So that's about it. We'll just save this. Just change it from the zillion to week, since we do not want to go on for very long. And that section is for weeks. And now we can choose whether we want to schedule now or create a cron job. I'll just go for schedule now. And this is the summary section where you can see what exactly we chose, what is the weight of the experiment. If my code is having any validation issue or not, any syntax issue, we'll be able to see this here. Which chaos agent we chose to target in this particular workflow and everything. So let me go ahead and finish the same. So once I finish, the chaos injection would start happening, and you can see potato. I'll be able to see which exact step is going on currently. So right now I can see the main application is initializing, and I also have this running on, like I have a watch statement on my terminal right now. So you can see exactly which pods are there in my particular namespace, Litmus namespace. So since I installed Litmus on the Litmus namespace, I have all these default dependencies or CRs that Litmus needs to run, which is the Mongo, the server, the front end, event tracker, and everything that you saw in the architecture diagram. And this is the new one. So potato head, this is the workflow, which is currently in creation state. So once this is created, we'll be seeing a lot of microservices pop up, which are these microservices. We had the left arm, the right arm, the left leg, right leg, and so many more. Now, once this is installed, this happens, this is successfully done. Currently, what it's doing is actually checking if the application is either there on the Litmus namespace or not. If not, then let's create it. If the target cluster is healthy or not. So it does all these pre-checks with the help of the chaos operators that I just talked about. So it's literally the heart of the experiment of the entire workflow, and it does a lot of things behind the hood. So now you can see that this check passed. So it'll go ahead and create a lot, like you can see creating a lot of stuff. So we have potato hat, it's creating one hat, and then you can see it's a hat's new. So left arm, left leg, right arm, right leg. Then this is the main one, which we'll be targeting to terminate in this particular experiment workflow that we just selected. So these are the different containers that have been created right now as a part of the install application. And if I do if I get a CC in my Litmus namespace, I should be able to also access this, which is this one, potato main, the node port. So if I copy over the port and I just let me paste it, and I would copy over my node IP in this case, and just access this, I can see that potato head is being currently created. As you can see, the arms are not yet done. And if I refresh this, maybe, yeah, one of the arms is done. If I refresh this, all the arms are done. So that is how the application is getting installed as a part of this step. Now you can see the application is done installing. So we can see that this is up and running. And if I just go to this terminal, you will see all the things are in running state because everything has been completed. So now what it's doing is it's installing the pod delete experiment. Now once pod delete experiment is installed, it will actually trigger the pod delete, when we can see, after which we can see that the potato main pod is being terminated. And once it terminates, it will restart back again, because it will try to restart back again. But since we have chosen a weak workflow, it would prevent to do so. So that will fail. But that's the gist of it. So when you do a chaos workflow, this is what happens, and it tries to terminate. And whatever the result of the termination, whatever the result of the workflow is, you'll be able to see. You can see the pod. This is being created. All right. So whatever the result of each of these nodes are, you can see. If you click on this, you'll be able to see the logs at the bottom. So this will give you a clear idea as what exactly is happening. And for each individual experiments, like pod network loss or pod delete or all these, we'll be getting chaos results. As you can see, there's an option for chaos results, which would not be available until the execution is finished, because you'll only get the verdict after it's done. So you can see the live logs of this while this is happening. And when this pod delete is executed, you will see the potato main pod is being terminated. So right now it's running for how much? About 2 minutes, 46 seconds. You will soon see that this pod would be terminated, and then it will try to recreate the same in this entire application. And once this entire workflow finishes, all these resources that were created as a part of the execution of the chaos execution would be cleaned up, would be gracefully cleaned up as since we had revert chaos option in our manifest. And so that is one way of cleaning all your resources if you do not want them to retain back. So that is mostly it about how you would use the 2.0 to create workflows. And this is a pretty straightforward process because you just go into the workflow section, you choose which agent you want to, yeah, you can see this is terminating. All right. You can choose which agent to target for execution, for workflow, chaos workflow execution. And then you just select whatever workflow you want to do. You can create custom, you can import YAMLs, and then you just schedule it now or create a cron job, and that's it. So that's as easy as it gets. And yeah, so once this finishes, if you just come back here, you would see that you would get an overall resilience score, which is also something that is a part of 2.0. And if you click on analytics, you can see what is the score, what exactly affected the score, and those sort of things. So yeah, that's mostly it about how you inject chaos with the help of Litmus 2.0. Also, we have all this mentioned in the docs. If you go to 2.0 docs and go to getting started, run your first workflow, we have these entire step mentioned in here. So you can see this is the same potato head workflow that I just ran. So you can go through this entirely and feel free to just schedule one and check for yourself what exactly is happening. And you do not need to install anything because it will install it automatically for you. So with that, I'll just share one last thing, which is the roadmap for the future of Litmus. So what we want to do as a future is we want to increase the support of chaos against the non-Kubernetes infrastructure that we currently have. So we have targeted AWS, GCP, Azure, but we want to increase the number of experiments that we provide for those non-Kubernetes entities, and we want to target more application-specific chaos experiments. Currently, we have Kafka, Cassandra, but we want to target more and more application-specific experiments. We also want to improve the chaos SDK for creation of user-defined experiments and make the process, the entire flow pretty smooth. We want to also add more and more probe types so that you can do custom steady-state hypothesis validation. So currently we have 4 HTTP, KTS, CMD, and PROM, but we want to add more to that so you can have more flexibility. We want to improve observability, of course, and we want to have more and more chaos types as we go forward. So that is one thing that we are really looking forward to with Litmus. And yeah, so this one finished. And you can see the lead application is in progress. And okay, so everything, a lot of that was created, the left arm, right arm, everything is gone. And now if I refresh, it would be not reachable because it deleted it automatically. So that's how you do this with the help of the portal. And yeah, that's about it for me. I would like to share it back to Prithvi, and he can take you forward with the contribution, how you can join the team.
Very, very good. Let's do it.
Sure, sir. And I think this is the last segment of the talk. So we'll just be talking about contributing to Litmus. I think a lot of people want to contribute, and contributing is something vital. So I mean, picking up good first issues is very vital. Checking the contributing doc, I think this is the last link I'll be sharing. But once you check the contributing doc, I think other than that, with Litmus or with chaos engineering, contributing is a little bit different. Usually people take a look at the code and so many things, but to contribute to Litmus, I think understanding what chaos engineering is and what Litmus is important. Checking the YAML files, if you want to contribute an experiment, then taking a look at the YAML files helps. And then obviously there are so many sub dependencies and the repos that are out there: chaos charts, workflows, testing tools, Litmus Go. I mean, Litmus is written in Go, so if you have some knowledge of Go, Kubernetes, Docker, containers, I think that'll be enough. But other than that, there are so many places that you can contribute to. You can contribute to the README, you can contribute to features, bug fixes, docs. I mean, documentation, we just built a new documentation completely. So obviously contributing to the docs is vital. And then obviously You can contribute to the website as well. On the front, the Chaos Center and the website are a couple of things where front end contributions come into play. And other than that, on the back end as well, there are so many things you can contribute to, especially to the Chaos Hub with Chaos experiments. As you know, the Litmus SDK helps you write your own Chaos experiments, and contributing that to the hub will be great. I mean, the links have been shared, and here you can find the code. I mean, GitHub is the place, and the main repo you can find the README and the major code, and on 2.0 as well. The latest docs are amazing. I think, I mean, that's a personal opinion, but I hope you like them too. Feel free to put out your opinion. You can check the version 1 docs, which talk about Litmus back when it was in 1.x. And lastly, inviting everyone to join us on Slack. Slack is the community where we all are present there on the Kubernetes Slack. Just join the Kubernetes Slack and at slack.kts.io, and then you can either use slack.litmuschaos.io or join the #Litmus channel. So that's it, folks. If there are any other questions, then I think Bart can put them forward to us, or you can ask them. And then
since we're a little bit over time, what I would like to do is to move this conversation into the Slack. But I think that everything that you put out there is really, really good, is to see how you can get involved a little bit more from that too. When you check out the Chaos, the Litmus Chaos website, how you can get involved, but also who you'll be involved with. There are some super, super cool people that are working on this project, so that I know personally. So I can definitely recommend in that sense too. One thing is the technical part. The other thing is the amazing people you'll get to work with. So can't recommend that enough. I think we got a lot of information here about, first of all, a great introduction to what is chaos, engineering in general, because you can never go too far back on that. Then seeing how all this has been built out with version 1, then taking on the feedback and realizing the room for improvement and things that can be added. Very exciting to see what's happening in version 2. And I think what's ultimately super clear here is that chaos engineering is here to stay, and it's only going to be growing. I think some of you may have seen, that there were predictions about which technologies were going to be big in 2021. And chaos engineering was one of them. All right, Cheryl Hung from the CNCF put that out there and very much said that there's only going to be more adoption of this. So it's a great time to be learning about it. Thank you both very much for sharing all the things that you share with us today. Great links as well too for folks that want to follow up on that. And then, like I said, I think we can definitely continue the conversation in Slack, because there are a few things we didn't get to, but for reasons of time more than anything else, I think it's good to wrap it up now. And then, like I said, we can continue the conversation later on in Slack.
Absolutely. Thanks a lot, Bart, for hosting this amazing session, and we look forward to the conversation on Slack. Thanks, everyone.
Absolutely. Thank you very much. Have a good one. Take care. Bye-bye.
Thank you. Bye-bye.
Cheers.